Hi everyone, it's time to go through the week 6 course notes, rates and ratios. Now we'll start with ratios. Ratios compare the size of two quantities in the same units. So let's look at this very basic example. We're mixing 7 kilograms of cement and 10 kilograms of sand. Okay, so the cement has a 7 on that side, the sand has a 10 on that side. And since they're the same units, kilograms, we don't need to write units in our ratio. Because if it's 7 portions to 10 equal size portions, it could be 7 buckets and 10 buckets, 7 grams and 10 grams. It doesn't matter. That's what the ratio tells us. 7 portions of this mixed with 10 portions of that. As for what goes on the left and right, well, there's no real convention in ratios in which should go where, as long as it aligns with the words. If we're saying cement to sand, it's 7 to 10. If we were saying sand to cement, obviously it would be 10 to 7. Okay, so whatever order we've put the words is the order we put our numbers. Now, as for simplifying ratios, well, we can look at 7 to 10 and say, yes, I can make a 7 kilogram cement and 10 kilo sand mixture. I can make 17 kilograms of concrete that way. But maybe that's not enough. Maybe I want twice that amount. So I'll times 2 on the left and I'll times 2 on the right. And obviously I will now use 17 kilograms of cement to, I'll use 14 kilograms of cement to 20 kilos of sand. Okay, I think that's a fairly logical approach, but also look what we're doing, it's fractions. I'm saying that 7 when compared to 10 is equivalent to 14 when compared to 20. So simplifying fractions and simplifying ratios is actually the exact same thing. I'm looking for common ratios. Now note that I started with the simplest form. 7 to 10 was the simplest form. I was just showing that it's equivalent to 14 to 20. I could have said 7 threes are 21 and 10 threes are 30. These are all batches of concrete with sand and cement in the same ratio. I could also have made a smaller batch. Half of the 7 is 3.5, half of the 10 is 5. I could have said just use 3.5 kilos of cement and 5 kilos of sand. These are all relevant ratios, but if we want to talk about what's the simplest form of a ratio, again, we started with it. This was the simplest form of a ratio. It's got no units in it. There's whole numbers only, not the 3.5 one, and they're the smallest numbers possible. Because 7 and 10, apart from number 1, have no further common factors. And we know from fractions that 7/10 would have been my last answer. I wouldn't have written the fraction as 3.5 over 5, no way. And I wouldn't have left it as 14 on 20. So we've got direct comparison here between ratios and fractions when simplifying. Now let's look at this next example. Again, it's talking about units that may not initially be the same, but we get them the same. Mixing 200 mils of cordial and 1 litre of water. Well, we can go cordial to water as 200 mils to 1 litre, great. But we need to know some conversions in this course. And one of them is just what does milli mean? And we hopefully know, and we'll get onto it later in rates where there's more of these, that milli means 1,000th. So a milliliter is 1,000th of a litre. In other words, 1 litre must have 1,000 of these little milliliters in it. So we convert 200 mils is in a ratio with 1,000 mils. 1 litre is 1,000 mils. Now they've got the same units, we don't need them anymore. 200 of a unit compared to 1,000 of the same unit. And we can see a common factor there, 200. There's 1 200 on the left, and there's 5 200s on the right. Here's the showing dividing both sides by 200. So the simplified ratio of cordial to water is 1 to 5. Great, alright. Page down please. And here's just stating that, yeah, it's exactly the same as a fraction simplification. Whatever we do to the left, we do to the right. But it's, again, times or divide. We can't plus 1 to the left and plus 1 to the right. That example of 200 mils of cordial compared to 1,000 mils of water. I'm not going to, if I want to make more cordial, I'm not just going to add 1 more litre of cordial and 1 more litre of water. That's going to be pretty strong. Okay, so we don't add stuff to try and make a batch bigger. We multiply it by something, or we divide it by something. No plus minus. Alright, here's some just different ways to express ratios. Josh earns half as much as Tim. In numbers, that's just saying, and we don't know what the actual dollars are, just the ratio. Like for every half of a whatever, $1, Josh earns, Tim will earn $1. But that's not simplest form just because it's a decimal. Okay, we want whole numbers. We don't want this half in there. So we've times the left by 2, or half times 2 is 1, and 1 times 2 is 2. So the ratio between Josh and Tim is 1 and 2. For every $1 Josh earns, Tim earns $2. Yeah, that's Josh earning half as much. In a childcare centre, there are 4 staff for every 14 children. Alright, staff, children, the 4 goes on the side of the staff, the 14 on the side of the children, and clearly 4 and 14 have 2 in common, they're both even, so we can halve both sides, and there's no reduction in a ratio of 2 to 7. Australian dollar being worth 75 US cents, this could be way out of date, I have no idea. But I've put the Australian dollar on the left and the US dollar on the right, and it tells us the Australian dollar, as in the Australian $1, is worth 75 cents US. Well, there's the Australian dollar, and there's the 75 cents. But of course, dollars and cents are different units, but they can become the same. You can compare 100 cents to 75 cents. We don't need the cents anymore. So 100 to 75, we spot a 25. It's in both of them. There's 4 25s on the left, 3 25s on the right. So 4 to 3 ratio. Another one, 1.25 hours compared to 20 minutes. Well, they're not telling us what they mean, but it doesn't matter. We're just putting a 1.25 hours on the left and 20 on the right. Now, be careful with these. I know we all know time, but it's easy to mess this conversion up from hours to minutes, because 1.25 hours, a lot of people accidentally read that as 1 hour 25 minutes. But 0.25 hours is literally a quarter of an hour. We know 0.25 is a quarter. I could go to the side and say, well, what is 0.25 by 60? Yeah, I could do that. I could use my decimal rules, or I could say, what's a quarter of 60? Or I could just work out what's a quarter of an hour. Half an hour is 30, a quarter of an hour is 15 minutes. These are all going to get the same answer. So I've got the 1 is 60 minutes, a quarter of an hour is 15 minutes. So just make sure you're getting it to 75 minutes. Not reading it as 1 hour 25 minutes, no, it's 1.25. So 75 minutes being compared to 20 minutes, I don't need the units anymore because they're both minutes. 75 to 20, they both have a common factor of 5, which brings us down to 15 to 4. Alright, so that's simplifying ratios. Now there's another format. Sometimes it's better to express a ratio in 1 to something format or something to 1. Now this statement here, 1 to x, it just means we're not talking about simplest form. That x could be a horrible decimal. Okay, I don't care. It's basically saying force the left hand side of the ratio to be 1 and the right hand side will be whatever it is. And this format, x to 1, is saying, yeah, force the right hand side to be 1 and the left will be whatever it is. In this survey of 1,028 Uni of Newcastle students, 338 stated that studying maths was their favourite way to spend the weekend. What am I doing now? I'm not a student. Anyway. 338 being compared to 1,028. So what I'm doing here is comparing the students that stated maths was the best way to spend the weekend compared to all university students that I surveyed. And when I force the left-hand side to be 1, how do I force 338 to be 1? I divide it by itself. Any number divided by itself is 1. So if I divide the left by 338, as long as I divide the right by 338, it's all good. And I get a ratio of 1 to 3.0, you know. Let's just be rough here. This might be for a student magazine. And I can say approximately 1 in every 3 students at University of Newcastle prefer to spend their weekend studying maths. So you can see it's got a practical sort of use. I would use a 1 to 3 ratio in an article much quicker than I would use 338 out of 1,028. 1 in 3 is much more catchier and straight to the guts of what it is. Note the data may be fake, totally made up. So if we're getting forced to turn either left or right into the number 1, all we're doing is dividing by itself. So here it's saying force the left hand side of the ratio to be 1. I started with 4 to 14, so to convert a 4 into a 1, I'll divide by itself. Got to do the same, divide by 4 to the other side, so it becomes 1 to 3.5. In the next one, it's the same question, but we've got calculators. It looks nasty, but it doesn't matter. force the left-hand side to be 1. Left-hand side is a 0.3. Well, 0.3 divided by 0.3 will give you 1. 1.4 divided by 0.3. Well, we're able to do that now, but there's no need. We've got our calc within this, and 1.4 divided by 0.3 is 4.6 repeater. And the next two are just the other direction. They're just saying force the right-hand side to be 1. Well, if there's a 10 on the right, divide both sides by 10. Done. Again, convert the right-hand side to be 1. The right-hand side is 0.06, divide by itself. Do the same to the left. Alright, so that's how to convert to a 1 to x or an x to 1 ratio. Now, problem solving using ratios. The first one's, well, very simplistic, but it just gives the concept that often there's two ways to, well, let's say there's always two ways to look at these ratio conversions, but more often than not, one way is just much simpler. In this case, it's a pretty nice one anyway. The ratio of the length to the width of your hand is approximately 2 to 1. For every 2 whatevers in the length, there's 1 whatever in the width. Okay, so it's just saying it's twice as long as it is wide. So if I say length to width, I go 2 to 1. Always make sure you get them in the right order. Length to width was 2 to 1. I've got everything lined up correctly. And then it says the width of Neil's hand is 9 centimeters. So in constructing this, I'm merely writing down the length to width. I'm writing down what I got given, that it was 2 to 1. Then I write down, well, the width of Neil's hand. I just make sure I put this 9 centimeter width under the W. And you can see then that my unknown is this box here. Now, how do I fill in that? And there's two ways to look at it. I can look at it, the first way I've done here on the left is I've seen a very clear times 9. This width of his hand is 9 compared to the ratio, which is 1. So it's like this batch I'm making is 9 times bigger than the ratio given. So just times 9 times 9. That says that 18 centimeters would be the length for a 9 centimeter width hand. Perfect. Okay, just 9 times the simplified ratio. The other thing which might make even more sense is just look at, instead of vertically, what I do vertically, I could have said, look, the right hand side times 2 gives the left. Hence, if the right hand side is 9, times 2 will give left. That's exactly what the ratio tells me. Whatever is on the right, the width, needs to be times by 2 to become what's on the left, which is the length. So, yeah, I had an unknown, and it didn't matter whether I looked vertically or horizontally, it was going to be the same answer, and I get 18 centimeters. Let's do that thing again. Read through the question. Sally works as a commercial carpet shampooer. She mixes shampoo with water, S to W, in the ratio 2 to 7 to use in her cleaner. How much water will she mix? 600 mils of shampoo. 60. Read the question, David. So it's shampoo, so I'm putting the 60 mils in the left column. It doesn't matter whether I put the units there or not. I can just deal with the number. I know that whatever answer I get is mils. But let's just look at my unknown is here. Now again, there's two ways to go about it, but one is probably nicer. I could say 2 times 3.5 gives the water. So for every 2 bits of shampoo, there's 7 bits of water. So compared to the amount of shampoo you put in, put 3.5 times more water. That's easier than the vertical one. It's like this batch is 30 times bigger. If I was using 2 mils of shampoo, I would use 7 mils of water. This batch is 30 times bigger than that. She's a commercial carpet shampooer. So 2 times 30 gives 60, and 7 times 30 gives 210 mils. So often there's one way that's just easier, and if there isn't, well, we could have done the 3.5. How did I know that it was 3.5? You'll see the working down here. I'm saying 2 times what gives 7. We do a little bit of algebra here to say if 2 times what equals 7, then that thing I'm trying to find, I divide both sides by 2. 7 on 2 is the thing I was trying to find. That was a way to answer. If 2 times something equals 7, then that something is equal to 7 divided by 2. Okay, but we try and find the nicer way to do it. What do we got down here? 3 sums of money. Okay, we got our first 3-part ratio. 3 sums of money are in the ratio 2 to 3 to 5. If the smallest amount, which is clearly the 2 bits, is $4.80, find the largest amount, which clearly must be the 5 bits. Now, again, when I say bits, dollars, cents, it doesn't matter. I'm saying that 2 parts of this amount of money was equal to $4.80. Hence, what's 1 part of this amount worth? Well, 1 part must be half of that, $2.40. So that means that's 2 times $2.40. This will be 3 times $2.40. That'll be 5 times $2.40. The question only asks for the largest part, so I do my 5 times $2.40, which is $12. Again, it's just the same as, like, maybe I said, look, for every 2 cents that's here, there's 3 cents here, and there's 5 cents here, and $4.80 is 480 cents. I'm just saying that how do I get from here to here? I times by 240. This batch of money is 240 times bigger than the original ratio, so every number just got times by 240. And how did I get the 240? I worked out 2 times what gives 480. Well, that'll be 240. So 5 times 240 would give me 1,200 cents, $12. Now, this is different. So there's 2 types of ratio questions. I'll just back up again. And we said finding one quantity when given another. So this is when we had got given a ratio, we were given one side, but one side was missing. Okay, now the next question says dividing quantities into a given ratio. So instead of getting given one side and finding the other, here you're given the total. And it says here's the total, now split it into the 2 bits or 3 bits or 4 bits. So it's different. It's not given one side, find the other. It's here's an amount, split it. Now the first question says Sam and Chris invested in a takeaway shop in the ratio 3:2. So for every $3 Sam put in, Chris invested $2. Maybe Sam invested $300 and Chris invested $200. Whatever it was in that ratio. Their business made a profit of $40,000, and we're looking at how much they'll receive if they share the profit in the same ratio as what they invested. In other words, Sam invested more, he should get more of the profit. So we're going to get this $40,000 and split it up amongst these 2 people. So the first thing we do is say, well, how many bits do I need to split this $40,000 up into? If I'm going to give Sam 3 bits, let's go buckets, okay? I'm giving Sam 3 buckets of money, and Chris is going to get 2 buckets of money. How many buckets do I need? 5. 3 plus 2. I need to split my $40,000 up into 5 buckets of money, okay? So normally I just say parts, and you can see here I'm saying 3 plus 2 is split into 5 parts. What's 40,000 divided by 5? Well, $40,000 divided by 5 is $8,000. So you're getting 3 lots of the 8,000, which is 24,000. Chris is getting 2 lots of the 8,000, which is 16,000. You can see I'd always do this adding up. 24,000 plus 16,000 does equal the 40,000 I was meant to split. And are they in the same ratio? Well, I know they are because I times by the same number. Equally, I could divide this by 8,000, it gets me to 3. Divide this by 8,000, it gets me to 2. It's the same thing. So it's pretty nice, and it's very practical too. We split things up into ratios. Let's look at the next one. It's a ratio of colours. To make the colour orange, red and yellow paint are mixed in the ratio 4:3. So 4 bits of red for 3 bits of yellow for this particular type of orange. How much red and yellow is needed to make 140 mils of orange paint? So it's the same question, because 140 mils of orange paint is not telling us how much red or yellow, it's telling us you want a total when mixed of 140 mils of this stuff. And if you look at, well, I need 4 parts of this compared to 3 parts of this. Again, I say, well, how many parts do you need? 4 plus 3, 7 parts. 140 mils on 7 is 20 mils. So that's 4 lots of 20 mils is 80 mils. That's 3 lots of 20 mils is 60 mils. I'll make sure that it still adds up to the total orange paint I want, and sure enough, 80 plus 60 is 140 mils. And is it still in the same ratio? Again, since I times by a 20 and times by a 20, they're still in the same ratio, and everything's good. Mix 80 mils of red and 60 mils of yellow, and we're good. The next one, okay, again we'll do it to the side. Let's read through carefully. A 2-litre container is used to make up an orange fruit drink. Okay, 500 mils of concentrate is poured into the container, and then water is used to fill the remainder of the container. Now, do whatever's needed. Here's my 2-litre container. 500 mils of concentrate, and then water is used to fill the rest. So I can see that whatever side I'm going to put C and W doesn't matter as long as I'm consistent. I'm putting the concentrate on the left and the water on the right. I know the concentrate was 500 mils, and I know since it was only a 2 litre container and it got filled up with water, well, 2 litres is 2,000 mils, so I must have added 1,500 mils of water to add up to that full 2,000 mils. And there, if you want to look at the simplified ratio, it says what's the ratio of concentrate to water in the fruit juice drink. Well, if I'd read the question carefully, it would have said, it says concentrate to water, so I'm glad I went C to W. It actually doesn't say in simplest form, but let's go for it. We should put ratios in simplest form if we can. I've got the same unit, so I don't need them, and I can see a common factor of 500. There's 1 500 is 500, 3 500 is 1,500. So this concentrate to water ratio is 1 to 3. Now, part B says 240 millilitres of the fruit juice drink is poured into a glass. How much of the drink is water? Okay, here's my glass. This is not to scale. And I've got 240 mils. And this was made in this ratio. So there's 240 mils in this glass, and I know the ratio of concentrate of water in that is 1 to 3 because it was mixed in the above ratio. So now the question is what? How much of the drink is water? Well, I know in this glass for every 1 part of concentrate, 3 parts of it is water. So it's now like the other questions. It's saying to me, split 240 mils up into a concentrate and water split, which is 1 to 3, where the total is 240. So how many parts do I have to break it up into? 1 part, 3 parts, that's 4 parts. So 240 mils split into 4 parts is 60 mils. So 1 of these 60s is 60. 3 of these 60s is 180. Yes, they add up to 240, but the question only wanted to know how much of the drink was water. That's how much. 60 was concentrate, but 180 was water. Almost fun, I'm hoping. Now, this next one. In an orchard, the ratio of orange trees to lemon trees, orange to lemon, is 3 to 1, while the ratio of lemon to mandarin is 2 to 5. Find the ratio of orange trees to lemon trees to mandarin trees. Sorry, totally had just a brain moment. Don't publicise it. O to L to M. Now the problem here is there's 3 orange trees for every 1 lemon tree. There's 5 mandarin trees for every 2 lemon trees. They're not the same thing. I'm not comparing lemons and lemons. But if I want to, like down here, I can say that a ratio of 3 to 1 is exactly the same thing as 6 to 2. So if I'm saying for every 6 orange trees there are 2 lemon trees, and for every 2 lemon trees there are 5 mandarin trees, that's the ratio. That's the middle one's the same. I'm saying that for every 6 orange there are 2 lemons, for every 2 lemons there are 5 mandarins. There's my ratio, 6 to 2 to 5. Oh, beautiful. So you've just got to make the common term the same by multiplying or dividing by whatever number, and now we can compare them. So now if someone asks me, well, what's the ratio of orange trees to lemon to mandarin? There's a 6 to 5. Or if someone asks me what was the ratio of orange to mandarin, it's 6 to 5. There's 6 orange trees for every 5 mandarin. Part B, if there were 390 of these citrus trees in total, how many of each variety are in the orchard? Well, we're exactly back to where we were on the previous page. We've got a total of 390 trees, of which 6 parts are orange, 2 parts is this, 5 parts is that. So how many parts are we discussing? 6 plus 2 is 8, plus 5 is 13. 390 on 13, that's 30 trees per part. So 6 30s is 180, 2 30s is 60, and 5 30s is 150. If I add them all up, sure enough they add up to 390, and that just tells me how many of each type of tree there was. 180 orange, 60 lemon, and 150 mandarin. Loving ratios. And now we move to rates. Now, the first issue, rates often or will contain a per statement when written in words. let's go through. We've got the rates of comparison when they're different units, like good old, I'm travelling at this many kilometres per hour. Okay, kilometres and hours can't be converted to the same thing, but I can say if I'm travelling at 60 kilometres per hour, that per is this forward slash, and it means over. This is the same as writing 60 kilometres over 1 hour, which is the same as the ratio of 60 kilometres happening for every 1 hour. Oops, I should put units. But the point is, we don't do ratios like that. Ratios we could at least convert to the same units, but you can see the analogy. Now, so we've got to note that, yeah, the word per means for every this happens, that happens. It's like a ratio sign. And like dollars per kilometre is how many dollars I'm spending, maybe on a taxi per kilometre, maybe on petrol. But we've got a list of conversions here, and yes, we do assume that this is either, well, it's knowledge for the course. Whether you knew it before or not, let's just look at what we're requiring. The 1 kilometre is 1,000 metres. Well, if you know kilo means 1,000, then it doesn't matter if it's metres or litres or a unit like candelas. It doesn't matter if we understand the unit. Kilo means 1,000. 1 metre is 1,000 millimetres, and a milli is on the other side. Milli is 1,000th. So 1 metre is literally 1,000 millimetres, because a millimetre is 1,000th of a metre. 100 centimetres, well, centi meaning hundredths. So a centimetre literally means 100th of a metre. So here's the metre, here's the 100th of a metre, and 100 of these centimetres make the metre. So I won't go through all these units because you can see it's just repeating that it's, you know, be it kilo, milli. We do go up to mega here. Mega means million, so kilo is 1,000 and mega is million. But we don't, there's further than that. We know from computers it goes to giga and tera and peta and stuff like that. If we used anything outside of this table, we'll tell you what it meant. Okay? But yeah, the highest we go is mega, and the lowest we're going, we don't even go to micro, we go to milli. So milli is 1,000th. So I think of, here's my base unit, like a litre. 1,000 litres is, so here I'm going to write a kilolitre. I'm going to write times 1,000, gets me up to kilolitre, and times a million gets me up to megalitre. But if I get a litre and divide by 1,000, I'm down to millilitre. Divide by a million, I'd be microlitre, but we're not going there. So there's our standard: mega, million, kilo, thousand, milli, thousandth, and also cent is chucked in there because, you know, it's pretty regular measurement. Now what else is there? A hectare. Seems odd that it's 10,000. Everything normally leaps in thousands, but a hectare is defined as a paddock, a field, a lot of land that's 100 metres by 100 metres. And if I multiply 100 by 100, it's 1 by 1 is 1 with 4 zeros. Hence, that's where the 10,000 comes from. So I don't necessarily memorise a hectare as being 10,000 metres squared. I memorise it being 100 by 100 field, but it's the same thing. 1 metre cubed is a kilolitre. I'd want to know that. Think of a 1 metre by 1 metre by 1 metre box, a very small water tank. A metre being, well, I won't try and do that on here, but that contains 1 kilolitre. In other words, 1,000 litres fits in this 1 by 1 by 1 metre cube. Another thing that's nice to know is 1 centimetre cubed is 1 mil. This tiny little centimetre cube that's 1 by 1 by 1 centimetre fits a millilitre of substance. Okay, and then the time. Hopefully we know our years, leap years and that. So anyway, let's do some examples. Let's Control A, delete P. Ashley made a 12-minute phone call and was charged $6. Find the cost of the call per minute. Now, the way I've laid this out, and you can do it all sorts of ways, this is going to be a very logical progression. So if you've got other ways to do it, it's all good. I've done it like the unitary method from last week, where I said, you know, this is what I'm given, this is what I want. What I got given was, Ashley made a 12-minute phone call and was charged $6. Now, the whole left, right, should I write $6 cost me, $6 was for 12 minutes, or should I write 12 minutes cost me $6? It makes no difference, okay? I'm just writing the relationship I got given. And then I see, well, what am I being asked? Cost of the call per minute means, well, if it's $6 for 12 minutes, and I only want to know 1 minute, I just look at the relationship. Clearly, it's divided by 12. And a 6 divided by 12, $6 on 12, well, 6 on 12 is a half, so it's half a dollar. 50 cents, whatever you want to call it. And you can see it didn't matter what I wrote on left or right. I'm still going to notice that I need to divide by 12 and divide by 12. And whether I answer is 50 cents or half a dollar. Perfect. The next one, exchange rate. Convert 130 GBP, British pounds, to Australian dollars at an exchange rate of 1 Australian dollar is equal to 0.65 GBP. Well, that's what I'm given this time. I'm given the exchange rate that 1 AUD will give me 0.65 GBP. What do I want to know? I want to know what 130 GBP is. Well, I'm going to write 130 GBP here and try and work out how to get from here to here. Now the truth is, I can get this answer straight from saying, look, if 0.65 GP is 1 Australian dollar and I want to know how many Australian dollars this is, just get 130 and divide it by 0.65 will tell me the answer straight up. But I'm just using the method from last week because a lot of people like it. If I say that, how do I get to know what 1 GBP is worth? How do I turn something into itself? I divide by itself. So if I divide by, I should write it over here. If I divide 0.65 by 0.65, I'm going to find out what 1 GBP is. If I get 1 AUD and divide it, I've got to do the same thing. So I'm going to get whatever the calculator says 1 or 0.65 is, AUD, is 1 GBP. And then to get from 1 to 130, I just times by 130. So it's a pure calculator exercise. That ends up saying, well, it's 200. So there was two ways to do it. I think this is a very nice way to set it out, even though I know I'm messy and I'm sorry. I'm trying to do the vertical screen. I need a detachable camera, so, or maybe I should turn the camera off. Who needs this? Anyway, it's a nice way to set it out, but if you can see the answer was just 130 divided by 0.65, fantastic. It's the same thing. Let's do some more. I'm going to try my neatest on this one. Lucia's old car uses 12 litres of petrol, costing $17.40 for a trip of 75 kilometres. Here we've got, well, 3 bits of info. Normally these things just give you, this gives this, and then we carry on with these 2 things. So depending on the question, we might have excessive information. We don't always have to use everything. Let's just try and make it clear what we're trying to find out. The first question, find the car's petrol consumption expressed in litres per 100 kilometres. Okay. Got nothing to do with the dollars question, eh? So I don't care about that $17.40 info. All I'm interested in, litres per 100 kilometres. What in my question compared litres and kilometres? Well, it said 12 litres is needed for 75 kilometres. That's what it told me. Alright? Now, what one am I trying to get? I'm trying to get how many litres per 100 kilometres. So I'm trying to get from 75 kilometres to 100 kilometres. And I could divide by 75 and go down to 1 and then times by 100, but as I've done here, it's staring at me that they're both multiples of 25. So to me, 75 divided by 3 will tell me how many litres I'll need for 25 k's. So if I divide by 3, that's 4 litres will be needed for 25 k's, and I know 25 k's times 4 will get me up to 100. And 4 by 4 is 16, so 16 litres will get me 100 k's, so my answer is 16 litres per 100 kilometres. Again, I like the method, but do as you feel. B was what's the cost of Lucia's journey per kilometre, so it's only talking about cost in kilometres. So I look at my question, cost in kilometres, well the cost it told me was $17.40, and the kilometres associated with that was 75 kilometres. And I want to know the cost of Lucia's journey per kilometre, as in I want to know per, that means per 1 kilometre. So I know that 75 kilometres cost us $17.40. I want the cost per kilometre. How do I turn a 75 into a 1? I divide by itself. So I'm going to divide both sides by 75, and if I get $17.40 and divide by 75, I get a $0.232 for 1 kilometre. In other words, 23.2 cents. Good. Alright. Now we've got this fairly common question. Kilometres per hour one. Metres per second, kilometres per hour. Now, it says Jamie Summers, a finalist in the World Athletics Championship, can run 100 metres in 10 seconds. Alright. 100 metres takes 10 seconds. And then it's asked to find a speed in kilometres per hour. Now the order I do here doesn't really matter, as in, I don't want metres, I want kilometres. I don't want seconds, I want hours. So I could do whatever order I want. But I know that I like to deal in whole numbers. So I know that if I convert from 10 seconds and go up to hours, she's going to be able to do, pretend that she could run at the same pace. I'm going to get a very big number here. If I wanted to start out by converting from metres to kilometres, I'd have to divide by 1,000. And I'd have to say, well, that's 0.1 kilometres. I don't know, I don't want to have to deal with decimals if I don't have to. So instead of converting this number and dividing by something, I'm going to convert this by timesing. So if I've got 10 seconds, my first step is, well, if I times both sides by 6, at least 10 seconds becomes 60 seconds as 1 minute. So 600 metres in 1 minute. And now I want to get to hours, so I'm just going to times by 60. And 600 times by 60, well, 6 sixes are 36, puts 3 zeros back on. There's 36,000 metres we times by 60, so that's 1 hour. And now I'd rather do my divide by 1,000, because 36,000 metres is 36 kilometres. Literally 36 kilo meaning 1,000. I started out saying, be neat, David, and look what happened. Oh, and I can't even talk properly. I divide by 1,000, so 36 is 36 kilometres per 1 hour. There's my answer, 36 kilometres per hour. So that was a nice progression. Let's check the next one here. Oh, no. I didn't mean that. I meant Control A, delete. Thank you. The next one says a tap is leaking at the rate of 15 millilitres every 10 seconds. Find the amount of water in litres wasted each day. So I want to get the mils to litres, and I want to get 10 seconds to each day, to a day. Again, I could convert 15 mils to litres and call it 0.015 litres, but no, I'd rather go the other one instead. Leave the 15 in mils, convert it 10 seconds, well, just like the other one. Times 6 will get us to 1 minute, and times 6 will get me to 90 mil. Times 60 again will get me to 1 hour, and times 60 here, well, 6 times 9 is 54, plus the 2 zeros. And I could already, if I want, I can convert to litres here, because I've already got to 5,400 mils. I could call that 5.4 litres now if I want. It really makes no difference, but I'm probably just doing this on the calc. 1 hour, well, I'll times that by 24 to get to 1 day, and suddenly I've already got my answer. 5,400 times 24 gives 129,600 mils. Divide by 1,000 gives me 129.6 litre in 1 day. That's how much we're losing, 129.6 litres per day. And we're done. Great. Okay, hope that was useful. I'm going to try and do another. Bye.